intentions, your parents probably won't let you stay out very, very late. It's a negative correlation. And some have just really no correlation. Like, I don't know, the number of aliens you own and your height, number of siblings you have and your grade. Probably doesn't have anything to do with each other. Yeah. We can also determine if things are linear or not linear. If you're in science, we love linearity. Linearity means it's a line. I know that in art, that's a line as well, but a line in mathematics is just straight. This is a curve. So this is not linear because it's a curved trend and not a line. We can also talk about the strength of the correlation. It's either strong or moderate or weak, meaning that this is the trend line. This is what the pattern we see, and our data points here are clustered closely around that trend line, and here they're pretty scattered. So like I know that this trend generally, the farther out you go on the X, the higher these points are on the Y, but it's scattered a little more than we'd like to have a really strong confidence in our line of best fit. These are the exact same, they're just negative. So this has moderate positive correlation, this has moderate negative correlation, medium cluster, and we can numerically talk about how well that's clustered, and I'll show you that in a second. So we can visualize outliers by if they're well away from the trend line. This is an outlier because it's well away off of the trend line. It doesn't really follow the slope. This one is not an outlier. It's still following the trend, right? As everybody's increasing on X, Y is getting smaller. And this is the same thing. This is farther out and very small Y. So it's still following the pattern, not an outlier, even though it's separated from the group. It's okay. It's like this is your, I don't know, ages and your number of friends. Right, and as you get older, you have fewer and fewer friends because you don't like everybody. And this is Mr. G, and I'm very old, and I have very few friends because I've driven them away with my bad math jokes. I don't know if that analogy makes sense. So again, number of pirates here. This is going backwards, right? But as the pirates increased, they're saying that the temperature would decrease, and that's just. One doesn't cause the other, right? So I like this, right? If an observer saw people with paraguas, umbrellas, on a rainy day, they might think that the umbrellas caused the rain because they see umbrellas on rainy days. And so this person might think, hey, if you pop your umbrella, it's going to rain. But that's just correlation, and it's not causation. And we have to be careful about those two. So here's a synopsis. We can measure this correlation using this idea. Like anything, I would maybe think about this as like a grade. If you're talking about 100%, your dots fit perfectly on your line of best fit. And if you have like 1 to 95, that's still pretty good. In my head, like 95% of the dots lay on the line. It doesn't really work like that. And there's this big ugly equation that determines the R value, the correlation coefficient, Pearson's correlation coefficient. But this is how I kind of remember. 1 means 100%, all of them lie on that. And as you get a little farther away from 100%, 87, we'd say this is very strong, moderate, weak, or no correlation. I'd like you to know this one, like, under 50%, that's pretty weak. If you had like, I don't know, if that was your grade, under 50%, like, kind of rocky. I know that overall, as you go farther out on the X, you get higher up on the Y, but I'm not concrete about what your value might be out here. Anything above 90, above 80 is strong. We'll give you very, very specific things, like a 95%, that's strong. A 20%, that's weak. And anything between there, it'll be pretty obvious that it'll be moderate. The range is from -1 to 1. If it's negative, it's all the same stuff. It's just pointed downhill. And we can calculate the R value using this fancy formula. We're actually just going to use this, right? So let's try it out. Oh, you're already there. So here's weight and maximum speed, right? There should be some correlation between those. As you get heavier, your maximum speed goes down. Now, I know that's not a perfect trend. We're not going to extrapolate. We're only going to interpolate. But I want to be able to put this in your calculator and have it give you an R value. So I want you, these are the steps if you want to take a screenshot of it or something. But I'll show you on my calculator right now. So these are your X's. We're going to put this in L1. These are your Y's. We're going to put those in L2, and we're going to describe the correlation between height and weight. Because just with this data, I don't know, right? And maybe we don't even know what these are, but we're just going to put the data in and like talk about X and Y. So let's put it in the calculator. Ba-bam, there's the calculator. And I put it in the stat list, and I said stat, said enter. And if you need to clear things out, you can go up into L whatever, hit clear, and then come back down. But I put in all these X and Y's, 85, you can follow those, and then put in L2 in there, or you can use this. Once you're done, you can say stat, go to calc, and then you can say you want a linear regression. Basically, I want a trend line. 4. Enter. Mine are kind of messed up. I want list 1. I hit second 2, second 1, second 2. And might as well just store it in the equation. So I'm going to say variables. You don't have to do this step. Function y1. I said please put that equation in y1. So it gives me the equation, and it gives me the R value. This R value, we're never going to use R squared. This R value is negative, so it's going downhill. As my weight increases, my speed decreases. It's fine. The other one is 0.8, so it's like, it's strong, right? I would say strong negative correlation to answer that question. So from there, you're good. You could visualize this data by going second stat plot, enter, my stat plot is on. I'm going to ask it for X as list 1. This is just gravy tricks if you want to. You can say zoom stat, which is 9 down here. There's all my data. There's my line. My equation has been stored in here for me, which is good. And then we can you can say trace and just pop through the values by going sideways. Right, so you can see this 100, 17, 83, 22. Here's 83, 22. That's this data point, right? So maybe that'll help you when as you're messing with things, but it just kind of bounces around from down the list. Cool. You could see like maybe this one would be a candidate for an outlier, but not this one. Neat. What is the solution? Yeah. Oh, moderate negative correlation. 80 is right on the verge. I think anything above 80 and you're positive, it's strong. Anything below and up to 50 is like moderate. So, close enough, Gorkevich. I want you to work some of these problems out of the packet, and here's some extra if you need. I used to think correlation implies causation. Then I just took a statistics class, and now I don't. Well, sounds like it helped. Well, maybe. Just like the pirates influencing the temperature. We don't know. Okay.